Continuing on, we have the algebraic functions, the sum, difference, product, and quotient of functions. So it tells us there to let f and g be two functions. The sum f plus g, the difference f minus g, the product f times g, and the quotient f divided by g are functions whose domains are the set of real numbers common to the domains of f and g, defined as follows. Alright, so first thing I want you to notice all of these. You see it has f plus g, f minus g, f times g, f divided by g, and it has an x on the outside of it. That is not times x. This is all notation here. That just means that we're taking the f function and we're adding the g function to it with respect to x, meaning its variable is x in both of them. So don't try to multiply everything by x. You're not going to do that. So that really just means we're going to take like our f of x function and we're going to add our g of x function to it. So if we have f minus g with respect to x, that means we're going to take f of x and we're going to subtract g of x. F times g of x means we're going to take f of x and we're going to multiply times g of x. And then f divided by g with respect to x means we're going to take f of x and divide by g of x. Now we're about to look at example 2, and I'm going to say example 2 only has one type of this, okay? So it's got an addition one, so we're going to add them, but we could do the same thing if we're going to subtract it. And then we would just take two things and multiply them if we're multiplying. And the division one is the one that you worry about, because when you do it, sometimes you're not sure what to do. Look and see if you can factor anything out so anything can cancel. If it does, do it. If it doesn't, then you can't do anything. A lot of times when you take f of x divided by g of x, there's actually no other work to do. So just know that. Alright, so let's try example 2 here. So example 2 tells us we're going to combine functions. So we're going to take, let me write it out. So example 2 says that let f of x equal x minus 5 and g of x equal x squared minus 1. It says to find each of the following. And A says we're going to find f plus g with respect to x. So remember, that just means our variable is going to be x. So we're going to take our f of x function and we're going to add our g of x function. Alright, so I'm going to put each one in parentheses first. So f of x is x minus 5 plus, and g of x is x squared minus 1. So how can we add those two together? Well, first let's distribute the sign in the middle here. So we get x minus 5 plus x squared plus a negative 1, so minus 1. And then we're going to combine like terms and write our variables in descending order, the exponents. So I see that these two are like terms, so I'm going to combine them. But I have a positive x squared, I have a positive x, and then that negative 5 minus 1 is negative 6. So this is f plus g of x. And then B tells us to find the domain of this. Alright, so just look at your answer. What did you get? Is it a fraction? No. Is it an even root radical? No. So those are the two restrictions we said we have to watch out for. So what is our domain? Well, if it's neither one of those, our domain then has to be negative infinity to infinity. So now I know I didn't ask you to do this, but if I'd have told you to find the difference of them, if I'd have told you to subtract them, you would just distribute the minus sign and then combine your like terms, just like what we did here. If it was multiply, if it had been f times g, f times g of x, then we know that means to multiply f of x times g of x. So we would have just had to take x minus 5 times x squared minus 1, and would have just had to do FOIL or distribute it, okay? And if it would have been f divided by g with respect to x, that's where we're just going to divide them. We would have taken the x minus 5, put it over the x squared minus 1, We just said there's nothing we can common factor out of the top or bottom. We can't factor the top or bottom any. So nothing cancels because the top's super glued together, the bottom's super glued together. So that would have been our answer there. All right, so just watch out for that because we didn't really have an example of it.